Hello everyone, this is the demonstration video for Group 30 for the course CS4296 Cloud Computing. I'm Ruth Lim, and together with my teammate Sifan, we will be benchmarking and analyzing the performance and cost efficiency of major serverless platforms, namely AWS, Google Cloud Platform, and Azure. Today, I'll explain the motivation behind our project, walk through our methodology, and demonstrate the AWS part. Sifan will then demonstrate the functions on GCP and Azure and share our findings. Starting off with the introduction. Why benchmark serverless platforms? Serverless platforms are popular for building scalable, event-driven applications. However, they behave differently depending on the cloud provider. For example, AWS may be fast to start, but Azure might actually be more cost-efficient at scale. So to explore this further and evaluate them fairly, we focused on three key performance metrics: cold start time, execution time, and cost per request. For our experiment, we designed two simple workloads to represent common serverless use cases. The first is a REST API that returns a personalized greeting based on the user input. The second is a database query that returns a user's detail based on a given ID. Our benchmarking process follows four main steps. Firstly, we coded and implemented both workloads using Python. We deployed the same exact logic on AWS Lambda, Google Cloud Functions, and Azure Functions. Then, we use Apache JMeter to simulate concurrent users, collect response time data, and measure performance under load. Finally, we collected the results into reports for comparison across platforms. Now, I'll demonstrate our AWS Lambda deployment. This is the AWS Lambda function that I have created, and this is the public function URL. And I have already uploaded the Lambda function code here. Now we will verify that the function responds correctly to both the REST API and the database query workloads using curl. Firstly, we'll run the curl for the REST API, and then we'll run the query for the database. Here we can see that the function is responding correctly. Now we will execute our JMeter test plan in the project directory. This test plan simulates multiple users and captures metrics like execution time, latency, and success rate. The output is in the results folder, and the HTML report here also shows the JMeter results.
Now I will do demos on GCP and Azure. As we can see here, I've uploaded the function for testing on Google Cloud. Then we ran the JMeter test script to get an aggregated test report. Next slide shows the result we got from JMeter. Similarly, for Azure, we uploaded our test onto the platform. Then we ran the JMeter test. And after that, we'll get the result for REST API and database query separately. Finally, I'll cover the overall results on the three platforms. Firstly, comparing the time spent, as we can see from the table here, regarding cold start, the difference between all three providers is minimal, suggesting comparable cold start optimization across cloud platforms. However, for warm start, GCP somehow has the slowest warm start time of the three, at 0.2 milliseconds. Azure's warm start is approximately 5 times faster than AWS and 10 times faster than GCP. Moving on to average response time, GCP outperforms both AWS and Azure for both REST API calls and database queries. Here, AWS and Azure show similar performance patterns, with AWS at 488.29 milliseconds for REST API calls and 458 milliseconds for database queries, while GCP's average response times are approximately 33% faster than both AWS and Azure. In conclusion, not considering free tier services, AWS appears most economical for workloads with shorter execution times. Azure might be preferable. For workloads with very low memory requirements, Azure's charging might become more competitive. And that's all for our presentation. Thank you.